the movies. Okay, so let me start the class. So in the previous class, we discussed the three. We started discussing the software process models. Okay, the first model is the waterfall model. Fine. So as I mentioned, okay, the process models, okay, can be plan driven or agile. Okay. So what is plan driven model? The steps are well planned in advance. So you are going to measure the progress against this plan. So this is what is called plan driven process models. The other one what we are having is what actually more important is or relevant is the agile processes, where correct no the planning is done incrementally, correct no. So that means at the end of a one particular phase, okay, you are going to assess, correct no. So we are not waiting till the end of the I mean we are not waiting till the end for the product to be developed, but rather what we'll do is we first develop a small part of the product, then we'll assess that product, then after taking the inputs from the customers, we are going to modify that product. So ultimately the intention here is the final product which is developed will should meet all the customer requirements, correct no. Why? Because the the change, many times I told, change is a fundamental part, correct no. So change is always change is always part of the software development process. So naturally, okay, you have to accommodate the changes, correct no, changing customer needs, correct no. So if we wait till the end, correct no, so you may not be, your final product developed will not will not meet all its features, correct no, expectations. So naturally the agile processes, okay, are more preferred. So the first model quickly, I'll go through that, the waterfall model. So I'll go to the presentation part. Okay. uh, okay, so the process models we started discussing. I told plan driven versus agile process. The first model is called waterfall model. It is a plan driven model. So you can see this diagram. Okay, the 5 different phases are there. Okay, so there is no backtracking here. So major disadvantage of the major disadvantage of, one second, the major disadvantage of the waterfall model is that there is no backtracking is there, correct no? So that means what? So the in any phase, okay, if you feel that something has to be changed or some new requirements have arrived, so it is not possible to include those changes. So naturally what will happen, if you start from the first requirement definition, you have to go in a the sequentially, we have to go in a sequential manner. That is, the next is the design is there, next is implementation and unit testing is there, then you have testing is there, and final operation and maintenance, correct no. So once the product is developed, going back to the previous stage is not permitted in the waterfall model. So ultimately what is the problem, what is the main drawback is that difficulty of accommodating change after the process is underway. So naturally, so when we can use this model, when we can use waterfall model, I told, only when the requirements are well understood and changes are very limited during the design process. So if you are very sure that the less changes are going to arrive, okay, then you can go for the waterfall model. But it is very quite natural that there will be changes, will be always a part of that, correct no. You cannot put a plan for 5 years, correct. You cannot expect that during the 5 years the requirements will not change, correct no. So naturally, okay, so that is a disadvantage or limitation of the waterfall model. Okay, one information, see, students should join because once I start the class it will be difficult, okay, because I have to switch over to the presentation and I have to go for admitting the students. So that's why I have sent the code at 9:10 a.m. Okay, so next class onwards I want that everybody, before starting the class, you have to join, correct? Otherwise I'll not admit the students. Anyway, fine. Okay, so the waterfall model is there. Then we have next what we discussed is incremental development. I told, okay, we are going to develop the software in increments, correct? No, so you have the initial version of the software. I mean, specification development, as you can see from the diagram, specification development and validation are interleaved, correct? No, so that means what? So with the rapid feedback across the activities is permitted. So naturally, it is a fundamental part of agile approach. So definitely it is better than waterfall approach, but of course some you know benefits are there. Cost of accommodating changing customer requirements is reduced. Why? Because the model will support accommodating change, therefore naturally the cost will be reduced, easier to get customer feedback, and more rapid delivery and deployment of the useful software. But of course the major two problem is that the process is not visible and the system structure will tends to degrade. Why? Because every time you are making the changes, you are permitting changes to happen, so naturally the structure will degrades. Anyway, that is about incremental. The third one, what I told about is reuse oriented software engineering. So the term itself is the reuse. That means you are going to reuse the existing components. They call it as commercial off the shelf systems. So you are going to reuse the already available components. So I'm not going to develop from the scratch. I will take the part readily available from the market. Okay, if you see, for example, I told no assembling is there, correct? No, so you correct. No, so what you can do, you can take the parts, correct? No, the parts are readily available in the market. You take it from the you buy it and you assemble in your product, correct? No, so this is the concept of reuse oriented software engineering. So here also what it means, here the systems are integrated from the existing components. They call it as commercial off the shelf systems, correct? No, so naturally the cost will be cost will be compared to the you can see this diagram. Okay, how the requirement specification, I have shown this component analysis, requirement modification, system design with the reuse, correct? Because I'm going to reuse the components, yes or no? So naturally the requirements has to be modified and the system design has to be system has to be redesigned with the reusable components. And of course the next thing is same, development and integration, and finally validation, correct? No, so first part you can observe that, so you have to collect the components, component analysis. So I'm going to search for the components to implement that particular specification, yes or no? There may not be exact match, so definitely so some modification has to be done. So this is the concept of what you call as reuse oriented software engineering. Okay, so as I told, okay, please join before the class starts. Okay, because there will be interruption will be there for me. Okay, so okay, next is the process activities. We started discussing the four basic activities are specification, development, validation, evolution. The first one we discussed called software specification. I told the process of establishing what services are required, correct? No, remember specification is nothing but focusing on what, okay, what you want from the system, what are the things to be developed, what are the requirements of the end users, correct? No, so these collecting those requirements, correct? No, specifying those requirements is becomes the part of the software specification. So I showed you the diagram, the requirement engineering process, very important. You can observe here on the top, you start with the feasibility study. Feasibility study is nothing but you make an analysis of whether the identified user needs may be satisfied using the current software and hardware technology. Means cost effectiveness. So you have to check whether the proposal system will be cost effective from the business point of view. Yes or no? And if it can be developed within the budgetary constraints. You can observe that. So I can develop a particular product only within, I mean, in two constraints. That is, one is the time is one constraint, budget is another constraint. Only if two are, if you feel that the two constraints are satisfactory, then only you can go for the development. So this is what we call as feasibility study. Next is requirements elicitation and analysis. I told what is requirements elicitation. The process of deriving the system requirements, maybe through observation. Sometimes we'll come to know, sometimes we learn about a system just by observing. You go to a factory, you be there from morning to evening. Okay, you will come to know what is the process. Correct? No. So this is what we call as observation. But every time we may not learn from the observation. So what you have to do, you have to collect the requirements formally, either through a, I told this, okay, to through a open-ended interview, or maybe by sending questionnaires. So this is the what we call as requirements elicitation and analysis. Remember, this is requirement engineering process. It's a separate chapter is dedicated for that. That is the fourth chapter. We are going to deal this in detail. So for the timing, you just know about the process, feasibility study, requirements elicitation and analysis. Once the requirements are collected, I need to specify them in a proper document. So this is most important because it serves as a reference. Where tomorrow I may be working today, tomorrow someone may join, correct? No, so he needs a reference. So I should properly document these requirements in a document. So then only, correct? No, so that is the purpose of what you call as requirements specification. And of course last one is requirements validation. Correct? No, remember, it is requirements validation. I need to check whether all the requirements are feasible, whether some may be valid, some may be invalid. So you have to retain only the valid set of requirements. So what is this below you are seeing here? You can observe here feasibility study. Okay, what is the output of this? It is nothing but a feasibility report. What is the output of requirements elicitation and analysis? Correct? No. So you will come across the system models, right? And what is the output of the requirements specification? So you will be having a set of requirements, user and system requirements. Next, last one, you can see that requirements validation. So what is the output of this? Output is nothing but the final thing what you are having, will be having is requirements document. What is requirements document? I told the entire, what is the output of this entire requirement engineering process is nothing but a requirements document. I told it serves as a reference. You can see something here, some you can observe here. Okay, backtracking is there, correct? No, if you feel that the requirements are not proper, you can always go back to the specification stage. From here again you can go back to the elicitation phase. You can see, remember, feasibility study is a separate part. Only if you are satisfied with the feasibility report, then only you will come across the, you will go ahead with the second, third and fourth process. Clearly you can see from the diagram, from a fourth step you can go back to the third step, from third you can go back to the first step. Okay, the first step is, remember, it is a separate thing. Okay, it is nowhere, so there is no question of going back to the feasibility study, correct? No, so first you have to do an analysis. Yes, whether my project will be completed within the stipulated time, and whether my project can be completed under the given budget, say for example 10 crores. Yes or no? If both constraints are met, then only you are going for the remaining part. Okay, so what is this reverse arrow mark? What it will indicate? It will indicate that there is always a possibility to go back to the previous stage, remember. And so this is on the topper side. Okay, the top, the fourth thing what you are seeing, okay, it is a process. What below you are seeing here, it is nothing but the output generated at each step. Fine. So this is what we call as requirement engineering process. Next, let me go to the second step, the second specification activity called design and implementation. Okay. So this is, remember, this is the second process activity. Already I mentioned design and implementation. So what is design here? So specification is nothing but, remember, okay, specification is nothing but finding out what is required from the your software. Whereas a design is the process of converting the system specification into an executable system. That is, the question to be addressed is how. Please try to differentiate between specification and design part. Specification is nothing but the term focused is on what you want from the system. But the question is how you are going to convert this specification into an executable system. That becomes a part of design and implementation. Okay, so here design and implementation are clubbed here. You can observe the activity here. Design and implementation both are not same. Design is nothing but, I told, no, preparing a sketch, correct? No, you have the set of requirements. Now you are going to design. Okay, correct? No, it is not coding. Remember, you are going to design the architectural design or interface design, database design, or you have component design. I will tell that. Okay, so remember that what is design. Okay, design is nothing but converting what into how. Okay, what is expected. Okay, and how you are going to convert that specification into the executable system, correct? How you are going to achieve this, so that becomes a part of design. Okay, that means what? It is a structure, software structure that realizes the specification. So you are going to translate the structure into executable program. So what is design? It will contain, design it will contain lot of diagrams generally. Okay, we will call it as data flow diagrams. We'll call as ER diagrams in database, because you require a database, correct? No? So you require a ER diagram. ER stand for entity relationship diagram. Okay, I told you you have a flow chart, correct? No? So all this becomes a part of what we call as a design. Okay, so design is not coding. Design is nothing but a software structure that realizes the specification. Okay, so and implementation is nothing but what? Implementation is translating that structure into executable program. So design is nothing but, okay, what is design? You are going to design a software structure that realizes the specification, correct? No, so specification you are going to convert into a structure. Okay, we call it as a design. The design you are going to convert into an executable program, correct? No, so that we call as implementation. For that you need a programming language. So design does not require, or design may not require a software, but it may require sometimes. Why? Because you need to design the interface, you need to create a database. Of course it is required, correct? No, so but the converting the design into implementation will require a programming language generally, correct? Executable program, correct? So design generally is not executable, but implementation should be executable. So please remember. Okay, the second process activity is nothing but the design and implementation. It is clubbed actually. In some textbooks they refer design is a separate step and implementation is a separate step. There is nothing wrong, but in this textbook what he has given is that design and implementation is one step. Fine. So they are related. I told, no, the activities of design and implementation are closely related. Why? Because, okay, if you feel that while during the implementation, if you feel that something is wrong, correct? No, you can go back to the design and modify your design. Yes or no? Once you modify the design, of course your program will change. Yes or no? So design and implementation can be interleaved. So this is the general model of the design process. Okay, so you can observe here. Okay, as I mentioned, okay, you have design inputs, design activities. The middle one you can see here, design outputs. Okay, so what is the input for design? Input for design is nothing but the requirements. If you try to understand in the broadly, okay, what is the input for design is nothing but the requirements. What is the output of the design? Output of the design is nothing but database specification, interface specification, component specification, and system architecture. So what are the design activities? So you can observe that the four major activities are the part of the design process: architectural design, interface design, component design, and database design. So what is architectural design? So here you identify the overall structure of the system and the components of the systems and their relationship. Okay, remember I told system is a collection of subsystems. Naturally, what is architectural design? Architectural design, you are going to identify the structure of the entire system. Okay, comma, the principal components, that is nothing but subsystems, and their interrelationship. System will be having a lot of subsystems. The subsystems are interrelated, correct? No, so only when the subsystems are interrelated, then only you can accomplish the the given task. So this is what we call as architectural design. What is interface design? So you define the interface between the system components, correct? Why? Because the interface should be precise. Without that, I mean, with the having a precise interface, the component can be used without other components having to know how it is implemented, correct? No, so you correct? No, that means what? The implementation of one component, okay, correct? No, so I mean, one component can be used without other components having to know how it is implemented. That means what? The interface design should be unambiguous. Okay, what is component design? I told system will have a number of subsystems. Each system component uh, has to be designed in separately, and it may be either a simple statement of an expected functionality. Okay, it may be a list of the changes to be made to a reusable component, correct? No, so that this is what we call as a component design, correct? No, then the last one is called database design. I told, okay, so naturally you require a database. When I say database, data structures, okay, you require, you need collection of data is there, correct? No, so you need to find out the methods for storing the data, okay, in proper data structures, correct? No, and how to represent this in a database, correct? No, so definitely you need a database, correct? No, for example, customer database, student database, correct? So you need sophisticated data structures to store the data. So remember, this is the general model of the design process. The first is input. Input is nothing but your requirements. The activities are four major activities: architectural design, interface design, component design, and database design. And the next one is the design outputs. What is the output here? The architecture, or maybe a database specification, or interface specification, or component specification. Fine. So I mentioned here architectural design, interface design, component design, and database design. Fine. So before that, I think before going move further, so the process activities, first one is a specification. So as part of that, we studied the requirement engineering process. The second one is a software design and implementation. So we studied the design process, general model of the design process. So from the exam point of view, these are important. Please note that. Okay. The third one is very simple now. We call validation, verification and validation. You know, the third process activity is nothing but verification and validation. What is the meaning of verification and validation? So you need to show that the system conforms to its specification and that it meets the requirements of the system customer. Ultimately, our intention is what? The customer, the software should meet the requirements of the customer. So cross verification of what? The the system execution with the specification. Correct, no? Correct, no? You need some you need certain thing to cross check. So what is that, with which one you are going to cross check? Against the specification, because specification you have mentioned in the beginning. Correct, no? So suppose I mentioned the temperature should be this. Okay, so there is a constraint, actually there is a specification. So after the development you need to cross check whether your system is meeting the its requirements. Correct, no? Whether your system will shut down in case of a failure. Correct, no? Or in case of a certain activity. Correct, no? Some suddenly something happens. Okay, the system should be shut down. Okay, so you are going to cross check whether your system or whether your software will meet its expectations. This is the part of what we call as software validation. Again, remember, the first activity is nothing but a specification. It is a separate chapter. We are going to come in the fourth chapter. Then design is a separate chapter, is dedicated. Even validation is nothing but testing. Okay, there is a difference between verification and validation. Okay, that will see in the testing part itself. Okay, what are the different types of the testing? What are the different types of the testing? So you can see that. Okay, we have the stages in the testing. Okay, the development testing, then we have system testing and acceptance testing. Okay, so testing I told. Okay, so the first one is what generally we call it as component testing or unit testing. I mentioned this in the previous class. What is unit testing? Unit testing is nothing but you checking whether the individual module, individual subsystem works properly. Okay, so suppose the system, imagine the system is having two subsystems. My first job is to check whether the two subsystems will work properly independently. Okay, I don't know, as far as possible the two subsystems should be independent. Okay, so my first job is to check whether the two subsystems will work properly. If they work properly, then I will go for what we call as generally, okay, integration testing. I need to integrate subsystem 1 with the subsystem 2. Then I need to cross check whether the integrated system is working properly. So generally we refer it as integration testing. Then what is system testing? You know that. Okay, once the system components are integrated, okay, to create a complete system. Now you need to find the errors that results from unanticipated interactions between the components. When two components interact, there may be some unanticipated interactions. Okay, or component interface problems. So the system testing deals with this particular part, that is whether the system meets its functional and non-functional requirements. Okay, again there is a difference between system functional requirement and non-functional requirements. Okay, so the first testing you can see here is called development testing. Some people call it as component testing, or I can call as unit testing also, because individual components are tested independently. Okay, independently. Now system testing is nothing but what? Okay, you test the system as a whole. Correct, no? In between you may have to do a integration testing. Okay, it is not mentioned there, but integration testing I told. Correct, no? You need to integrate two different components. Correct, no? See, for example, we have a Pratham Shetty, please unmute. Pratham Shetty. Pratham Shetty. Pratham Shetty is not there. Pratham Shetty. KP Pratham Shetty. Pratham Shetty is not there. Am I audible? Am I audible? Please put in the chat box anybody. Yes, okay. Where is KP Pratham Shetty? Pratham Shetty. Pratham Shetty. Unmute. Pratham Shetty.
Sir, he has network issues, sir.
Network issues.
Yeah, I WhatsApped him, but it's not reaching.
Okay. See, I told again, okay, I want everybody to join before the class starts. Okay. So otherwise it gives me that interruption problem will be there, correct? No. So see that before the the given time you should join. Okay. Maybe 5 minutes is somewhat can be accepted, but see now students are at 10:04. Okay, I started the class at 9:30, right? And I have put the shared the link at 9:10 exactly, correct? No, even also students are joining now at 10 o'clock, correct? No, so this I cannot accept. Okay, so will not in future, please remember this. Okay, okay, you should join before the class starts. Okay, even because I will also get interrupted, correct? I have to switch over between the presentation and all these things, correct? So see that you join well in advance. Okay. uh, okay, validation we are discussing, the development testing, system testing, acceptance testing. So what is the first one? Development testing, also called as component testing. You are testing the individual components. What is system testing? You are going to test the entire system as a whole, correct? No? I was giving the example, correct? No, so you for example you need to correct. No, so you need to integrate the components. You are going to integrate different components into your system, correct? No? So first you should check whether the individual components work properly, correct? No, after that you do the integration, then you check whether the now whether the system is working properly, correct? No, because the components may be working fine independently, but when you integrate, it may give some unanticipated problems. So your job is to check the that is what I told, system testing. You have to check the system as a whole. And last one is called acceptance testing. This is most important, correct? No, testing with the customer data to check that the system meets the customer's needs. So finally, what is acceptance testing? As the name tells, okay, system should be acceptable. When the system will be acceptable, when the system meets the customer's requirements, correct? Then I can say that the system is acceptable, correct? But again, acceptance testing can be of two types. Okay, for your information. Okay, I will share one slide with you. Okay, you can see, observe, they call it as alpha testing and beta testing. Please remember, acceptance testing, this will come in the separate chapter. For the timing, what is acceptance testing? You are going to check whether the system meets its specified requirements, correct? No, but again there are two categories, broad categories. They call as alpha testing versus beta testing. Generally, alpha testing is performed to identify all possible issues before releasing the product to everyday users. Okay, alpha testing is generally done at the, you can see that the table. Okay, is generally performed by the testers who are internal employees of the organization, correct? No, alpha testing is done before the product is released. So it is performed at the developer's side. Remember that who is going to develop the product. Okay, the alpha testing is done at the developer's side. Why it is done? To identify all possible issues or errors, correct? No, so the focus of this testing is to simulate real users by using a black box and white box techniques. So generally it is carried out in a lab environment and usually the testers are internal employees of the organization. Okay, fine. But so this kind of testing is called alpha only because it is done early on, near the end of the development of the software. When it is done, it is just before the end of the development of the software, this testing is done. Okay, we call this as alpha testing. So remember, alpha testing is done before beta testing. So what is beta testing then? Beta testing is a product, sorry, beta testing of a product is performed by the real users of the software. See, ultimately the software who is going to use, there will be, the, it is not, it will not be used by the developer, it will be used by the client, that is the end user, maybe for example bank employee, bank clerks, correct, bank manager, correct. So they are the real users of that application. So beta testing is done at the performed by the real users who are really going to use that software, correct. So this is what we called as external user acceptance testing, because it is done in a real environment. So you can see that is different table. Okay, I'll share this. Okay, beta testing is performed by the clients or end users who are not employees of the organization. It is performed at the client location or end user of the product. Okay, so this is the major difference between alpha testing versus beta testing. Okay, alpha testing is done before beta testing. Okay, it is done at the developer's side to identify the possible errors. Okay, whereas beta testing is done at the client location, correct, by the real users who are going to use, because when they use the system, because they are going to use the system, so when they work with the system, they will come to know what is uh, the real problems. So beta testing is performed at a client location or end user of the product. Okay, so anyway, alpha testing requires a lab environment or testing environment. Beta testing is does not require a testing environment. Why? Because the software is made available to the public and is said to be a real-time environment. Correct? You run the software in a real environment. Correct? No? With the actual people who are going to use the system. Correct? No? So naturally, it will give a more weightage. Why? Because when they work with the software, they will come to know whether it is user friendly, whether it is needs to be updated, whether it something changes has to be done. Correct? No? Because they are the real users who are going to work. Correct. So remember this. Okay. So this is the one point I wanted to mention you, that is called as alpha testing versus beta testing. Fine. So this is about the third process activity. We call it as software validation. Okay, it has, you can see that component testing, then system testing, acceptance testing. Correct. So again, it is a you can observe this. Okay, so there is a cycle is there, loop is there. You can go back to the previous one. Correct. Yes or no? Then from acceptance testing, you can go back to the component testing. Correct. No. Then yes or no, you can go to the system testing, or directly you can go to the acceptance testing. So this is what, correct. No? One component may be need to be modified. Okay, and the last one is called what you call as, so this is the testing diagram. Okay, testing phases you can observe here. Okay, so you observe here requirements specification. Next is you have system specification, system design, detailed design, and the unit test. Then from there you can observe that integration test, subsystem integration test, system integration test, acceptance test, and service. You see this cycle how it is. It is a flow chart. It is a flow chart. You can observe. Okay, so right from here. Okay, for the time being, just be aware of this. Requirement specification, system specification, sorry, system design. Of course, you have a detailed design. Let me not discuss about all these things now. Then you go to the unit test. After unit test, you go for the integration test. You go for the system testing. Then you go for the acceptance testing. So then you are going to put the software into service. Correct. No? So acceptance testing, again, it is having two types: alpha testing versus beta testing. Remember, alpha testing is done just before the beta testing. Okay, it is done at the developer's side, whereas beta testing is done in a real environment. Last activity, process activity, there is nothing but a software evolution. I did not speak much about this. Why? Because evolution is nothing but changes. Okay, so I told it is a adaptive maintenance, corrective maintenance becomes part of the evolution, correct? Because the evolution is a separate, it's a dedicated chapter, need to be is there. So we'll discuss that. Okay. Fine. So software evolution. So four major activities: specification. Second one is the design and development. Third one is validation. The fourth one is software evolution. Fine. You can see this. Okay, the diagram for system evolution: define system requirements, assess existing system, propose system changes, modify the systems. Fine. Then you see you will come across the new system. Okay. Then you cross check, correct? Now because you can see that once you have existing system, this is the existing system, you can see here. Okay, and here is a new system, correct? Now and there is always a possibility to backtracking is there, correct? Existing system is here. Okay, so you are going to assess the existing system and you are going to propose any changes, and with that changes proposed, you are going to modify the system and you will arrive at a new system, correct? No? And you need to assess that. Fine. So you can see that it is a continuous process, correct? No? It is a continuous process. You cannot think that, you cannot assume that yes, the new system has been developed, yes, it works fine. No. Okay, you have to assess the system and you have to propose the changes and make the changes. So that's why I told evolution is a, please carefully go through these diagrams. Okay, it is not that just in the class. Okay, you will you're going through this diagram, correct? No, I will share these materials to your Google Classroom. Okay, after that you start reviewing the things what I have done so far. Okay, what is the requirement engineering process, what is the I mean the general model of the design process. Okay, then what is the stages of the software testing. Okay, I'll prepare a set of questions. Okay, and I'll put it in the again Google Class, so that you will have an idea of what the topics what we have discussed, correct? So that is you should have a clear idea on the topics what we have discussed. So let me prepare a word file. Okay, let me frame some questions and I will put it in the just for reference. Okay, and don't write assignment. Okay, I will tell that. Okay, later, this is just for information to you people. Okay, I will prepare the topics discussed. Okay, and you can refer the either the textbook, I mean the soft copy is there, I will share it. Okay, so that you can have a comparison. Okay, so next is the next point what we are going to do is same. Remember we are in the chapter 2 only. Okay, coping with the change. Okay, the next topic what I'm going to discuss is coping with change, because I told change is always inevitable. Okay, change is always a part of the large software projects, correct? No, changing platforms require application changes, but the change always leads to rework. Yes or no? Change always leads to rework. So the cost of the change will include both rework as well as the cost of implementing new functionality. Yes or no? When you do, when you change always leads to rework. Why? Because it will the cost of it will include the cost of changes, cost of implementing the new functionality, and cost of reanalyzing the requirements. Okay, so this is what we call as the change. But how to, the question comes is how to reduce the cost of the rework, right? As I mentioned in the previous slide, change always leads to rework. Okay, the cost of the change will include both rework, that is nothing but reanalyzing the requirements, as well as the cost of implementing new functionality. Now the question is how to reduce the cost of the rework. There are two approaches, they call it as change avoidance and the change tolerance. What is change avoidance here? Change avoidance is nothing but the software process includes activities that can anticipate possible changes before significant rework is required. Okay, so for example, a prototype system may be developed to show some key features of the system. What is change avoidance? Let me repeat. Okay, what is change avoidance? So you anticipate possible changes before the major rework is required. So that is always better, correct? No, so instead of waiting till the end, okay, and because it will incur the cost. Naturally, what is the best method is that you anticipate the possible changes in the beginning itself, right? So for that only what we call as the prototype. I will come to that prototyping. Please highlight this prototype system. Prototyping is a technique used to show some key features of the system to customers. Okay, I am not going to develop the actual system. Okay, I will generate only a prototype. I hope everybody knows, have come across this term called prototype. Correct? No, it is not the actual system. Correct? No, it looks like the correct. No, the product may be it may be very similar to the actual system which you are going to develop, and you are playing with that prototype. Okay, and you are going to modify that prototype. Correct? No? Yes or no? So this is the best option, actually best method to for reducing the cost. Otherwise, as I mentioned, okay, the cost of rework is high. Correct. No, cost of rework is always high. So what is the one method to reduce the cost of the rework? You develop a prototype. Correct. No, once you develop a small prototype, okay, and you will come to know, okay, what are the plus, what is the plus points, what are the negative points, what is to be developed, what is missing, what is unwanted things are there. Correct. No, you take the feedback from the people. Correct. No, then you modify that prototype. So naturally what will happen, okay, it is not like the waterfall model where you start from the step number one, then you go to step, step number one is specification, then last step you develop the product, then at the end of the, after developing the product, if you feel that okay, the product is not satisfactory, you know what will happen. I told the three things: time, your effort, and the cost. That is nothing but money will be wasted. So no. So because you are waiting till the end to assess the product, so that is not acceptable. Correct? Because it will involve huge cost. So what is the best method? You go for a prototyping approach. Okay, we'll discuss this in detail. That is, you develop a small version, initial version, we call initial version of the software system, that is used to demonstrate the concept. Correct? With that prototype, you are just demonstrating the concepts. Okay, and you are showing some options. Correct? No, so you are just you will you correct? No, you will come with a trial versions. For example, I think, I hope everybody is knowing. Correct? No, suppose you develop the, I'm sorry, you buy the software, they may give you for a trial version. Correct? No, so it is free of cost. You need not pay for that. You use the trial version. Correct? No, for few days. Correct? No, then you will decide whether to buy or not. Why? Because depending on whether it is user friendly, whether it is flexible. Correct? No, so it may not be an exact example, but it is a very similar example I gave. Correct? No, the trial versions of the software products. Correct? No, you use that when you use that product, the trial for the during the trial period, you will come to know, yes, whether I have to go really purchase this or not. Because you will come to know, correct, what are the loopholes, whether it is really working, whether it is whether it is able to do the task assigned, no, yes or no. Correct? No, so you will decide. After that you will decide whether to buy or not. Correct? No, so that same way. Correct? No, so same way here, prototype is nothing but a initial version of the software system that is used to demonstrate the concepts. Correct? No, so this is what we call as a change avoidance. The other one is what we call as a change tolerance. You design the process in such a way that changes can be accommodated at a low cost, but this normally involves some form of incremental development. Okay, because the proposed changes may be implemented in increments. Already we have come across the incremental model. Okay, So change tolerance is nothing but the process is designed so that the changes can be accommodated at a relatively low cost. Okay, so there are two approaches. One is a change avoiding the change is one method. Avoiding the change in the future is one method. So what is the solution for that? You develop a prototype. Correct, no? You demonstrate that, you test it. If you feel that something has to be done, you modify it and you throw the prototype. Generally, we call it as throw away prototype. Throwing is not in that sense. Throwing, that means you are discarding that prototype. Correct, no? This is one approach. The other approach is this change tolerance. I mean, you design the software in such a way that the software can tolerate the changes at a low cost, significantly low cost. So both approaches can be suitable, okay, depending on the situations. So please try to remember how to reduce the cost of the rework. Okay, change avoidance, change tolerance. So okay, so what is the method for change avoidance? You are going for the system prototyping approach. Okay, where the version of the system or the part of the system is developed. Okay, quickly to check whether the customer's requirements and feasibility. Correct. No, if if you are able to identify the number of requirement changes, okay, then you can easily modify the prototype. Correct. And after that you throw the prototype. Throwing again, it is not like that. Okay, throwing in the sense you are throwing the, you are discarding the prototype. Whereas the other one, what we call as a incremental delivery, it becomes part of change tolerance. Correct. No? Why? Because the system increments are delivered to the customer for comment and experimentation. Okay, the software is delivered in increments. First increment, second increment, third increment, and so on. If the first increment will have a limited feature, the second increment will have a additional feature. Correct. So you give it to the people. People will experiment it. Fine. So this, please remember what are the two approaches for coping changes. One is a prototyping approach. One is the incremental approach. Both we'll discuss. Okay. So first, let me discuss the software prototyping. Okay. So prototyping. So what is prototyping here? Prototyping is nothing but a initial version of the system that is used to demonstrate concepts and try out design options and find out more about the problem and its possible solution. So when it can be used in a software development process to help anticipate changes. In the requirement engineering process, a prototype can help with the elicitation and validation of the system requirements. In the system design process, a prototype can be used to explore particular software solutions and support user interface design. So the system prototypes generally allows the users to see how well the system supports their work. So from that, people will get new idea for requirement or find areas of strength and weakness. So what is the use of prototype? You are going to find areas of the strength and weakness. So based on that, you are going to propose new system requirements. So, and you see that as the prototype is developed, what will happen? It may reveal errors and omissions and in the requirements that has been proposed. Okay. So the system prototype may be used while the system is being designed to carry out design experiments to check the feasibility of a proposed design. Okay, so the diagram you can observe. Okay, so what is prototyping? What you have to remember is that prototype is a initial version of a system which is used to demonstrate concepts and try out to design options. Correct me. So the next stage in the process will be to decide what to put into, and perhaps more importantly, what to leave out of the prototype system. Okay, so that means what is more important in the prototyping is that first, see what the benefits. Okay, benefits are improved system usability. Okay, then a closer match to the user's real needs, improve design quality, improved maintainability, reduce the development effort. Okay, so I will show you the diagram here. Okay, the prototyping, the process of prototype development. Okay, so establish prototype objectives, define prototype functionality, develop a prototype, evaluate a prototype. Okay, so the first, what you have to do, you start with the prototype objectives. Okay, then you identify the, or you define the functionality. What to be put into and what has to be leave out of the prototype. Okay, so this will help you to reduce the prototype cost. Then you design the prototype, and now you need to evaluate the prototype. Okay, that means what? The provision has to be made during this stage for user training, and prototype objectives should be used to derive a plan for evaluation. See, remember, you can see the diagram. Initially you have a plan. Okay, then you have, at the end you have a report. Okay, at each step you can see you have output here. The first one is prototyping plan, the next one is outline definition, executable prototype, and evaluation report. Yes or no? So you are going to cross check the evaluation report with the against this plan. Okay, so what are the major advantages is that it may, there is some, it may be impossible to tune the prototype to meet non-functional requirements. I'll come to that functional versus non-functional requirements. Okay, maybe in the next class. Okay, but it may be based on rapid prototyping languages and tools. I told, uh, you know, uh, uh, RUP, that stand for Rapid Unified Process. Okay, it may involve leaving out of functionality. Okay, prototype should focus on the areas of the product that are not well understood. What is the advantage? What is the what is the ideal intention in the prototype? Should focus on the areas of the product that are not understood. Error checking and recovery may not be included in the prototype. Remember, prototype is not a complete software. It is only one stage model. Correct? No? So error checking recovery is generally not included in the prototype, and focus on the functional requirements rather than non-functional requirements. What is these non-functional requirements? I will tell later. It's reliability, security, robustness, etc. We'll not discuss now. Okay. So I told, generally prototypes are the prototypes. Why? Because prototypes are discarded after development because they are not a good basis for production start. Right? So I told this usual word called throw away prototype. Correct? Because the prototype generally will not meet the normal standards, quality standards. Okay. So it is only for, to get an idea, get an insight into the product developed. Correct? No? This will not meet any quality standards, and error checking, error recovery also is not part of the prototype. Naturally, I'm going to discard this prototype. Throw away prototype. The name tells throw away. I'm throwing prototype. Throwing in the sense what? Discarding the prototype. Why? Because my intention, why it is used prototypes? Prototypes are used to focus on the area of the product which are not well understood. Correct? No? So once you come up with a prototype, if you feel that you have covered all the important aspects of the product, definitely you can discard the prototype. Okay, fine. So yeah, uh, the incremental testing will take in the next class. Okay, so what is the, let me come back to this. Okay, so what actually we have, uh, so what we discussed in the today's class is, the thing is regarding the three different models: waterfall model, incremental development model, and one more is what called rapid unified process. Okay, So what we it is reuse oriented software engineering. Okay, the first one is waterfall model, the incremental model, and the third one is the uh, reuse oriented software engineering. We discussed the four major activities: specification, design and implementation. Third one is validation. Fourth one is evolution. Okay, then we discussed about the concept of what we call how to support change. Okay, how to reduce the cost of rework, change avoidance, change tolerance. Change avoidance, actually what we are discussing, change avoidance is nothing but uh, okay, sorry for the interruption. Change avoidance is nothing but change avoidance is nothing but problem approach. Okay. And change tolerance, let me discuss in the next class. That is nothing but the incremental delivery. Okay, so but in the next class, before I take up, please come prepared. I like to ask some questions. Okay, so far whatever I've discussed, I just want to have a review on that. So all the students should come prepared. Okay, so let me ask random questions to you people. Okay, please come prepared. Okay, meantime I will share the material. Okay, so any questions are there? Any questions? Anybody?